hope this answer would work for you for now. And without further ado, let's start the lecture. So, hope you're ready since we're going to cover some interesting things about Node.js in this lecture today. And so as you see, we are going to talk about Node.js API today. Kind of the fundamental APIs which you would use very often, though you might not um, get the idea that you are using them, and even in your first homework. So let's take a look at the agenda. But before, my name is Sergey. I work at LeverX for 4 years now as software engineer. You can contact me by this email with any questions you would have after the lecture. Something about myself. Actually, I was hired to LeverX after this Node.js course. So I've been in your shoes, guys. I know it can be hard sometimes, and there are a lot of things happening concurrently. But you actually, it's really not that easy to find the time to invest in this course, especially with the size of the homeworks and the short deadlines. But keep up the good work, and you'll have a lot of benefits from this course. And so let's go to the agenda. Today we'll talk about how is memory managed in Node.js and what are the differences with other languages. Then we'll cover the kind of basic built-in Node.js APIs, such as event emitter class, buffer streams. Then we'll have a look at the file system module and when you could use it and why. And then we will have a short introduction of Express library, which is used to create web servers in Node.js. So let's start with the memory management. The general memory lifecycle in your application kind of looks like that. First of all, you need to allocate the memory for your variables, for your functions, for your objects, and all types of data, which is used in your application and should be first allocated. Then you're using them, you're assigning new values, you're comparing them with each other, you send them in the response. And after all the actions which are required to execute using those variables are finished, you need to release the memory because you don't want to, ideally, you don't want to store anything in the memory which is not currently used. So in lower level languages like C or C++, those steps are quite not such abstract in like in Node.js, because in those languages you have to manually allocate the memory or release the memory. And I think many of you guys had an experience with C or C++, maybe in the university, maybe in some spare time you just wanted to have a look at how this language works. So, and actually there might be some problems with releasing memory because you can simply forgot to release your memory after the execution, and this memory would stack up in your heap and would cause memory leaks over time. So you won't have any free memory to run your program. In Node.js, the things are not so low level. Basically, Node.js provides you with a garbage collector, and a lot of higher level languages has its own garbage collector. Java, C#, basically all of them have garbage collector, and Node.js is not the exception. So what garbage collector does? Garbage collector lets you focus on memory usage, on using your variables, and it frees you some time on allocating memory and releasing the memory, since garbage collector does it for you. So you can imagine this like you have a function with some variables, object, arrays declared, which are used exclusively in this function. And when you call this function, the memory should be allocated for those variables, objects, and other data structures for them to be available in the scope of your function. Then you execute the function, you actively use those variables and data structures, and when the function execution is finished, basically when the first return word is executed, then you no longer need those variables, so this memory can be freed up. So basically, that's the sole purpose of the garbage collector, to get rid of things you are not using anymore. But yeah, there are a lot of advantages for the garbage collector comparing with the manual memory management, but it's not a silver bullet, guys. So you should as well keep track on how you're declaring variables and how you use them. Are there any references in your code which are referencing to the objects you are no longer using? So garbage collector, it kind of looks at all of the references which are declared in your code. And if there are some which are still can be referenced from the main execution flow, then they won't be garbage collected. So that's the thing you need to keep track of, even though you have the garbage collector. So maybe any questions about garbage collector? You can type them in chat. And
I have a question.
yeah, sure.
Is there any scenario where we need to manage the memory by ourselves manually? Any scenario in Node.js?
No, not directly, but not from the code perspective, I would say. But you can face the situation where, for instance, you're running your Node.js application on the server, which is very low on resources. Like ideally, Node.js requires to have 1.5 gigabytes of the memory. But for some reason, your server has only 512 megabytes of memory for Node.js. And yeah, actually, you can face the situation where your application is running, there are no memory leaks visible from the code perspective, but still you, when you look on the heap graphics over time, it would be slowly increasing in memory consumption till the point it has no more resources. And this can be caused because garbage collector actually have no resources to start. So in order to fix this situation, you can specify the flag when you run your Node.js, it's max hold space flag, and you should specify the amount of RAM available. So Node.js runtime would know that we are running low on resources, so we need to be careful and we need to have some spare resources to run garbage collector in this instance. But yeah, from my experience, I never faced such a situation where I would like to manually manage the memory, since everything is managed by the garbage collector. Yeah, hope
Okay,
that
thank you.
answers your
Understood.
question.
I have also one question about it.
Yeah, sure.
Yeah, also what you told and about manual. For example, we faced manual scenario or not actually. In these both cases, can you somehow just see visually what it collects or see logs or something?
Yeah, sure. You can like Google Chrome provides you with very rich tooling for tracking your memory heap. You can also grab a memory heap from your application and import it to the Google Chrome. And Google Chrome DevTools would show you how your memory was consumed and how it was used, and would show you do you even have memory leaks or not, or you can just basically a lot of application have some monitoring created in them. So, and there are actually dashboards. Those are custom solutions for sure, and you need to add this functionality in your application manually. But you can actually track from inside your application, from inside your server, how much memory do you consume at specific point in time. And you can, after that, go to your monitoring tool, which is third-party tool like Grafana or something else. It doesn't matter for now. And it would show you the graphic of how your memory consumption was, like kind of amount of megabytes on this axis and the time on this axis, and you would kind of see this graphic. And if this graphic increasing, that means you have memory leaks. If it's stable, like the linear graphic, then everything's fine. Your garbage collector is working and you do not have memory leaks. So kind of like that. There are a lot of tools to track this, but the easiest one would be the Google Chrome DevTools. Yeah.
Yeah, I will of course take a look. It's so interesting that you explained.
Yeah, I can just share some articles after the lecture.
Yeah, would be great.
Yeah, I'll send them in chat.
Thanks.
So we are done with memory management. Now let's continue to the event emitter. The event emitter is kind of very fundamental class for Node.js, because a lot of Node.js classes and APIs extend this class or use it inside. So like streams and basically a lot of HTTP module is an example of how we can use event emitter. So the event emitter is can be the implementation for the observer pattern. So do you know, guys, what this observer pattern is?
No, actually.
Yeah, let's cover it a bit. So we would have the observer pattern coverage in much more details in further lectures, but for these lectures, let's just look at some basics of observer pattern to have an understanding how event emitter can help us. So let's say you are creating a Twitter or X, whatever you like most. And basically, Twitter provides you with the functionality to follow someone. And following means whenever they create a new post, you would receive the notification as a follower. And you only receive the notification when you follow the specific account. So kind of observer pattern works in the same behavior because you can imagine that we have some observable, which is our Twitter account, and we have observers. The observers are actually the followers for this account. And whenever the new post is created and published by the observable, it is treated like the state change, and whoever wants to know about state change gets notified about it immediately. So basically, that's how the observer pattern looks, and event emitter in Node.js looks in the similar manner. So you have some observable you can observe basically and receive any notification on any state change. yeah, so kind of event emitter implements the observable pattern in that way. But some can argue that event emitter is rather the implementation of pub/sub pattern, which is very arguable topic I won't talk about for now. But yeah, you should keep in mind that observer is not the only pattern which is used to receive reactive notification about some change. Pub/sub can help you as well in this situation, but they work in different manner. Yeah, maybe you have some questions about the observer pattern. Is it clear for you?
Yes, I have a question. With Observer, we only just notify subscriber, or also we can send data.
Yeah, you can also send data, which we would have a look at when we would speak about the event emitter in Node.js. So yeah, you can send the data. Of course, you can send the specific change which was created, a specific update for the state, or you can basically send anything you want. You're not limited. But yeah.
This would be with a subject, yes? So to
Yeah.
send and receive.
Yeah, the one who is sending is the subject. The one who is listening is the object. But it kind of terminology, but yeah, after all, you just can imagine the state like something abstract, and whenever there is an update for the state, you would receive the notification in your observer. Basically, the entity which is observing the state changes, the state, and would like to act on any state change. So
I have
yeah,
one question
sure.
about Observer. It notifies subscribers at the same time, or in chunks or something like this. For example, if you imagine that 1 million users or 2 million users follow one account, how does it handle?
Yeah, those are the topics which are basically not set in stone. So whatever use case you need, you should follow this use case. For instance, if you have million users, you might not have the resources to have million subscribers to handle this state change. So you need to create something to handle this load, but maybe you would have only one listener or two listeners, like feasible amount of them. Then you should not it would be obsolete to handle this much of users or listeners in this case. So basically, it's not defined in the observer. Yeah.
Is it possible in observer that, let's say, an observable object or the subject, it has like several components, I don't know, name, surname, something like that, and there are observers. One of them looks at just name. If the name changes, something happens in another component. If surname changes, then the other component listens to it. Is it possible? Does it work that way or not?
Yes, it's possible. And yeah, when we would have take a look at the event emitter class, yeah, that would make the better understanding for the observer pattern. So yeah, let's go on. So as you can see, this is the event emitter actually. And answering your previous question, yeah, so you can have several events. So in your example, those events can be different fields which have been changed. And for each event, there are listeners specified. And those listeners would react to only one event they are listening to. And you can send as many events as you want. Basically, if you have the new field added, you can create the new event, which would be emitted when on this field. update. And yeah, actually, it doesn't really matter for you whether someone listening to this event or not, because it's anyway would be emitted, and it's only a matter of do you need to handle it or not. So as you can see on the slide, as I said, we can have several events to be emitted from our observable, and we can have like several listeners to one event. We can have non-listeners, we can have only one. Basically, it depends on you. How much logic do you need to execute whenever this event was emitted? So now let's take a look at more feasible things. So basically, that's the event emitter class in Node.js. By the way, do you see the code? Is it visible for you?
Yes.
Yeah,
Yes.
it's visible.
Nice. So how to use the event emitter? To use the event emitter, we need to create the instance of the event emitter. And after the instance was created, we can use it. So there are several methods in event emitter. Let's go one by one. First is on method. So this method is used to register the listener for this event. So as you can see here, we have the event name, which is just a string, the name of the event, which we are listening to. And the listener is a function which would be executed whenever this event was emitted. Next is once method. It works in a similar way as on method, but the only difference is it's been executed only once. So after the first execution, this listener is removed from the from our observable list of listeners. Then we have emit method. This method is used to emit the event, as it says. So you need to specify the event name which you are emitting, and you can provide some arguments. They are optional. You can just emit the event without arguments, but if you provide those arguments, they will be passed directly to the listener. So answering the previous question, yeah, you can send anything when you emit the event, and this data would be passed to the listener code, and you can work with this data inside of your event listener. And then we have some utility methods after. Event names would return you an array of all the events which are currently emitted by this emitter. And we can also have an insight on how many listeners do we have registered for the specific event by using the listener method. This method would return you a number and this number is the amount of listeners which are currently listening to the specific event from which were registered with on method, once method, and etc. So let's take a look at real world example, close to real world example. And yeah, here you can see how we can use the event emitter. So in order to use the event emitter, we need to import the event emitter class from the events module. And after we have imported that, we are creating the emitter object, which we would use in order to listen the event and emit events from. After that, we are creating the event listener, which is invoked whenever the created user event is called. For now, we just log in the data in the console, nothing special. And then we are creating the user, which is the object. We specify some fields, the user data. And after the user is created, we are emitting event, user is created, and we're sending the user details. After we doing the emit created user, we instantly go to our event listeners, which were registered at the time being, and we execute the logic synchronously. So this example can teach you that in order to have the event listener being triggered, we need to register this event listener before we are emitting the event. Because JavaScript is being executed line by line, and order matters in JavaScript. And if you won't declare the event listener before you emit the event, this event listener won't be triggered. Yeah, you can treat them like triggers in the database, kind of in the same manner, but the difference is you can emit events on anything, not only created user, maybe users been read, any other stuff which is happening in your application. You can use the event emitter in order to react to that. So you are not restricted for only some options where you can use it. Basically, you can use it instead of function calls if you prefer, but it doesn't make much sense. Yeah, so let's have a look at the differences between on method and once method. So we have very similar code snippets here. And when we look on the left-hand side code snippet, we can see that we are registering the event listener as in previous example, and we are emitting the event called event twice. And as we expect, this listener is being triggered once, twice, basically as much as the event was emitted. But when we have a look at the right-hand example, here we see that basically code is pretty much the same. The only difference is we are using .once method to register the event listener. And when we emit the event first time, yeah, we have the expected result. It prints 1. The 0 was incremented and we have 1 in the console. But on the second emit of the event, we have nothing in the console since we have declared the listener is once method. And as I said, the listener which was registered with once method would be called only once. And basically it gets removed from the event listener from your emitter object after the first call. Then let's take a look at the event names, and this method can also teach us something. So as you can see here, we have two event listeners which are being registered to be invoked on the start event. Two other have different event names and in test. And if we want to have a look at which events can be emitted, which events are listened to in this emitter, we would call the event names method. And these event names would return us only 3 array with length of 3. Yeah, because basically all events are unique and you cannot have duplicated event names. And for those two first emitters, they would be called on the same event. So you need to emit only once for those event listeners to be triggered both. So that's something that you keep in mind as well. You do not have events with the same name in one emitter object. Then we have listener count, and this listener count method we have two event listeners registered which are listening to the event start. And when we want to have a look at how many event listeners we are having for the event start, we have two, yeah, as we have declared, nothing special here. And yeah, of course, in event emitter, there are some default events which you do not manually emit. and ideally you shouldn't override them since they are more like utility events and they provide you with some improved functionality in some cases. So let's have a look at those events. The first event, which is emitted by default, is the new listener. So it's pretty straightforward. It's kind of whenever you register the new listener for your emitter object, you have the new listener event being emitted. Remove listener. Whenever you're removing your event listener, the event remove listener is being emitted. And interesting detail that this remove listener event is emitted after the first execution of the event listener, which was called with .once method. So yeah, you can have a proof that this listener is actually removed from your event listener. And then we have array event. This event is pretty interesting because you can override some Node.js behavior by listening to this event. So for instance, you have the error being thrown from inside your event listener, and you can expect for your node process to crash on this error. But you can prevent the node process from crashing when you register the event listener, which would be invoked on the array event. So you need to just type .on error, and actually instead of crashing, Node.js will give responsibility for you on error to act on the error, do some error handling, and yeah, so the main feature of this event is that you can prevent your app from crashing. And yeah, that's all about the event listener. It was pretty fast. Maybe you have some questions, maybe something wasn't clear for you.
I have one question.
Yeah.
What will listen count print on event once? Only one, right?
No, listener count, you mean?
Yeah, sure. I forgot that lane.
So the .once is more like the runtime thing. So when you have 0 events emitted, you would have printed as many listener counts as there are currently registered in the emitter object. And of course, if you have the listener been removed, it doesn't matter actually whether it was removed because it was declared with .once method and was already executed, or you have removed it manually. So after deletion, this listener count would change because it's dynamic value, of course, and during the time you have different amount of listeners registered, and at specific point in time you have different numbers. So yeah, if you have the listener which was created with once method, and this listener has already been triggered, then you have a decreased amount of listeners in your listener count call.
Okay, yeah, thanks.
I have a question. How does the error event fires? We fire it, or it is fired automatically when there is an error?
Yeah, so it's the default event. So basically all of those default events are fired automatically, and specifically the error event is being fired whenever the error is being thrown from inside any listener. So you do not need to know which event it was, which listener it was. You would receive it just an error which been thrown. So you can imagine it like wrapping your event emitter in trackage, kind of. So it would be thrown automatically whenever the error is thrown.
Okay.
So that's direct correlation. Yeah, let's continue with the lecture, and now we will talk about the buffer. So buffer is the class you won't use very often, but you won't use explicitly very often. But the buffer is widely spread across Node.js, and many classes support buffers, many modules support buffers. But yeah, the main purpose of the buffer is to be used with the stream. But yeah, so what's the buffer is? Buffer is the class to handle binary data. So it mainly focuses on manipulating the buffer, and basically it is the class which is the representation of the to represent the data which can be read only in only by your CPU, like the binary code or anything. So it's not human readable data. Actually, you can receive the buffer when you read from the file without any encoding. You would just receive raw data, which is a buffer, and it can be interpreted only by your computer. Yeah, so as I said, buffers are mainly used in streams, and interesting part that buffer can be converted to the string when you provide the encoding you need, and every string can be converted to buffer. So those classes are work together. The buffer and the string data type, they working tightly together, since it's the only type which can be which you would use to create the buffer from. And yeah, as I said, it mainly used in streams, and we would cover streams in further slides. So yeah, like it's pretty simple. Buffer is a static class. You just need to import it and you can use it right away. You do not need to create an instance as you had to do with the event emitter. And in this example, we are creating the buffer from the string hello world, and we provide an encoding for this class to know that this string has UTF-8 encoding, and we would receive the buffer from the string. After we have received the buffer, we can turn it back to string, but with different encoding. For instance, hex or base 64. So yeah, as I said, buffer can be converted to any string. Then we can have some insight on how buffer looks like. So by logging it, so it's not very meaningful data, you won't understand it most likely, but your computer will, and your computer is the only guy which is capable to do this. And yeah, you can provide different encoding. That would mean that buffer would know that this string is having this encoding, and the buffer would be different. And now, yeah, maybe some questions about the buffer.
Can you tell us a real world example about buffer?
Yeah, sure. You're reading from file, you receive the buffer, and then you use the stream to work with this buffer by work with the chunks of this data, not the whole data at once. So, buffers.
We should always use buffer, for example, when we have this data, yeah, computer data, I mean.
You kind of do not have other choice. Node.js chooses for you. For instance, if you read from file without providing the encoding, you would receive the buffer because it was not encoded. So you do not need to manually specify this. It's something which comes out of the box for you. So yeah, the main usage of buffers is streams, and streams are the main consumers of the buffers, I would say. But before we start, let's speak about what streams are not. So the streams are not about multi-threading because, as you know, JavaScript is single-threaded language, but they are more about reading the data not as whole, but reading the data by small parts, the chunks. And yeah, the normal function won't be able to work with the stream because normal functions are work with the whole data, which is kind of an object or a string or something else. But streams are not the normal type of data because it potentially might have no end. It potentially can be endless. And whenever you use stream of data, it doesn't mean that it would have an end. So yeah, the streams would rather return you a small portion of data. And for instance, if you can imagine, if you would ask for example, the example would be is we want to read we have the big file, like 1 gigabyte file, and we want to find a specific combination of words in this file. In order to do this, it would be not very optimal to load this whole 1 gigabyte file into memory, then convert it to encoding we need, because it consumes a lot of resources of the application. And yeah, it would be much more convenient to read this file by small parts and process the small part to find a combination of words. And when we find this combination of words, we do not longer need to have the stream, and we can close it. So actually, streams provide you with a huge functionality to work with some big data or work with any other things which are very heavy, but you do not want to waste all of your resources for one specific task. So streams come in handy. And yeah, streams are exclusively working on buffers and strings. And yeah, kind of that how the stream would look like, how the processing of the huge file would look like with the stream. So basically, we have the buffer on the input, which we have received from the file, and we receive the data by small portions, by the chunks, which come over time. We can process these blocks of data one by one. So in this slide, we have already processed 4 chunks, and we are about to process the 5th chunk. And yeah, the important thing about the stream is that it's using the event emitter. It extends event emitter, and it has some events which are being emitted from the stream directly, which you can listen to read the data. There are different types of streams. Yeah, the readable stream. Readable stream, we can only read data from the readable stream. We can give nothing to the readable stream, so we can only read from it. We have writable streams. Writable streams are the ones which do not give you anything, but you can give your portions of data to the writable stream, and it will be processed by the consumer. Then we have duplex stream. Duplex stream, it actually implements the functionality of the readable stream and the writable stream as well. But yeah, you can as well read and write to this stream. And then we have the transform stream. This type of stream can be used if we need to do some data manipulations from inside. So those are examples of where you can find the different types of stream in Node.js. So for readable stream, it would be a request, HTTP request, or you can get the read stream from the file system. So for instance, you read the file, and instead of reading the whole file, you can create the read stream out of this file and receive the contents of the file chunk by chunk, instead of once as a whole. Then we have writable streams, and we can see writable streams in HTTP response and in file system writable streams. So kind of the same, but completely opposite. You can specify the file name and read to this file line by line, for example, or chunk by chunk. Then we have duplex streams, which are TCP sockets or web sockets, as you know them. And basically, this type of the connection between two servers, which is real-time communication. So you are having the mechanism to transfer the data and the mechanism to receive the data. And you can both read and write to this duplex stream. And then we have transform streams. So we need to transform the data in some way, and we can find the stream in zlib streams. So we are archiving the data using this stream. And yeah, basically that's it about the types of the streams. Now let's take a look at how we can use them. But maybe any questions about the types of streams, different types of streams?
Tachi had a question in chat.
So if we use map filter reduce, does Node turn the data into a stream like how it is in data? Now, map filter and reduce are the array methods, and array have the elements in them. And in the array is not a stream because array is has an end, and you can receive in any function the whole array at once, and you can work with the whole array, and you know that there won't be anything new in this array. So that's the difference between array and the stream. And the arrays are not transformed into the streams when you use the array methods on them. Hope that answers your question. Now let's take a look on how we can create read stream and use it. So for this example, the FS module is important, and the easiest way to get a readable stream is to get a readable stream from a file. Exactly what we are doing here. So here we have some file txt declared, created, and we are creating the read stream out of this file. So yeah, basically that's the only thing which is we need to do, and before we would work with the stream directly. So in order to, we have some events which are being emitted from the stream, which is data and an error event. So when you register the event listener for the data event, basically that's the event listener which would work with your, that would receive your, chunk of data. So you'll receive the contents of the file in this event listener by chunks. Then we can listen to end event. This end event would be emitted when the file is finished, when we hit end of the file symbol. And then we have an error event, which we can listen to. And as you remember, the error is the default event of event emitter, and this event has been thrown from the event listeners, and this listener is being triggered whenever this error is being thrown from the listener. So I've seen the question in the chat. Is Socket.io a duplex stream? Yes, because it helps you, because it's the library used to establish the communication via the WebSockets. So, and the WebSockets are the representatives of the duplex stream. So yeah.
Sorry, I have a question too.
Yeah, go on.
So are we able to use on method because streams extend event emitter class?
Yes, yes. Streams event emitter class. And here we are creating the stream, but we are using the event emitter methods on the stream. And we can use them because stream extends event emitter.
Okay, thanks.
So yeah. Then we have writable stream. So for writable stream, it's pretty easy because we just creating the write stream from the file system as we did with the read stream. But the difference is we do not listen to to the data event because we cannot receive any chunks here. But instead, we would only write to the write stream. And as you can see, here we're writing each index on the new line. And we can benefit from using the write stream here because if we wanted to create the file with the complete content of these 2500 lines, first we would need to wait until this loop is finished. Then we need to wait until this whole string is being written to the file. But with the help of the streams, we are able to do it line by line without consuming many resources. So there is a mechanism in Node.js to work with the streams. It's called piping. What the piping is? So let's take a look at the example first. So here we are creating two streams, readable stream and writable stream. So the idea behind this example is we want to copy the contents of this sample.txt file to a new file.txt. So in order to do this, we can use pipe method. So what it would do, it would take each chunk which we receive from the reader stream and would give it to the writer stream. So basically piping meaning that we are we are providing the output data of the first stream to the input data of the second stream. So yeah, basically this very convenient way to work with streams. And more to that, piping is not exclusive to the Node.js streams. For instance, in the bash, you can have piping as well. It's this line symbol, and it would take a look at the output of your command and then do some logic which you're piping it to. And another thing which you should know about, that you can pipe as many streams as you want. So if you would need to transform the data from this readable stream before writing it, then instead of directly piping it to the writer stream, you would pipe it to the transform stream and then pipe the transform stream to writer stream. So basically you can have a lot of these milestones and build up how your streams would work. And yeah, as I said, it's pretty convenient way when you just need to have the output of the first stream to be input of the second stream. And some theory. All streams are the instances of event emitter, and streams work on the strings and the buffers. Streams are storing data in the internal buffer, and there are two modes for readable stream, which is important. The flowing and the paused mode. So in this example, we are having a flowing stream. What does it mean? So we receive data whenever this data is ready. We do not need to call any function to get the data. We do not need to unpause it. We just receive the data as it is ready. So it's flowing stream. And the difference with the pause stream is that we need to explicitly call a specific function to get the data from the stream. So it might be, so we won't receive the chunk as it is ready by the stream, but rather than we explicitly specify the moment when we want to read the stream. So those are two main differences between those two modes. And yeah, streams are unique because you do not need to store all the data in your memory. You just need to store a small chunk of this data. And after this chunk has been processed, it would be erased from the memory and we are ready to work with the second chunk. So it is a bad practice to kind of declare an array or something and to store each chunk we receive in this array, because it kills the whole purpose of the stream. And maybe instead of using stream, you can just read the whole content of a file, for example. So yeah, you can find streams and use streams in very big amount of cases. And this the very convenient way of working with the data Node.js provides you with. So for now, let's take a small break for 5 minutes. Will 5 minutes work for everyone? And yeah, see you in 5. So guys, are you back? Are you refreshed?
Sure.
Yes. Nice. Maybe some questions before we proceed, since we have covered the vast majority of this lecture.
Yes. Can we store images in the buffers?
Yes. Sure, you can store any type of file in the buffer, since, as you know, the files represented in the file systems, and at some point they are stored in the binary data, and the buffer is specifically for storing this kind of data. So yeah, sure, any type of file can be a buffer, or basically anything. And you can even imagine, yes, go on.
And can we read the two streams at the same time?
Yeah, why not? But it kind of comes tricky because it depends, because JavaScript is single-threaded language.
Yeah.
And we can actually read both streams if they do not have chunks created in the same time. So that's the reason why you would like to use paused stream, for instance. So you won't have this type of concurrency between them, and it's quite more manageable for you to. So you would have you need to pick the stream you want to read from explicitly, but of course you can create two streams and register the event listeners for the data event, and that would make your streams to be read concurrently, even though it's the JavaScript, it's no concurrency in here. So yeah.
Thanks.
The question from the chat is, RxJS works with streams, right? It more kind of works in the event emitter style, and in the RxJS, this kind of division between the event emitter and stream is erased in some way. So they provide you with the observable object, which is different to promise. So when you have a promise, you need to call the await, and you would receive one specific result, and there won't be any results left. But with observable from the RxJS, you can receive not one result, but you can receive many results which come over time, like chunks do. So in this manner, it's very close to the stream, but RxJS do not guarantee you that you would receive more than one and even one chunk in comparison with promise, because promise would give you the result eventually. And yeah, basically RxJS is the library which is kind of reactive library, they call it like that. And it's mainly used in the Angular frontend framework. And they treat it like we have the framework which operates on streams, which is very reactive, even though there is already one reactive library called React. But yeah, so Angular enforces you to use streams, and every data transfer and every DOM change which you receive in Angular comes in the form of the observable from this RxJS library. It's basically very interesting library. It provides you a huge vast majority of tools to work with the streams, like piping, merging, whatever you want. Basically, it has implemented it already for you. So I can send you the link for the documentation of this library for you to get familiar with, but in my experience, I haven't used RxJS on the backend very often, but there are some cases. Yeah, LinQ is from C#, right? RxJS is basically like a LinQ for JS. No question from chat, and I'm not sure because LinQ is. Yeah, I don't have the insights on the LinQ since I'm not very proficient.
I can say that, I'm sorry, I can say, if you don't mind, that RxJS and LinQ are absolutely different things. Sorry to interrupt you.
Yeah, because from as far as I remember, LinQ is more like used as some convenient ways to work with the data structures and something else, while the RxJS provides you the interface to work with observables, which is chunks. Yeah, I don't know about the creator of the LinQ, but yeah, still, you can ask me these questions after the lecture, but now let's go on with the file system module. Yeah, that's the built-in module in Node.js, and basically, as it says, it gives you the interface to work with the file system in your project. So you're wondering why would you even need file system in your project? But yeah, there are a lot of things like the configs, like the ESL interpreter you have configured in your first homework. They are just config files, and they, in order for them to have some influence, they should be read from the file system, and file system module helps from with this. Basically, each file, whenever you read the file in your Node.js application, you are using the file system. Maybe you're creating the logs file, which along with creating the logs in the console. There are many implications you can use file system for, but the main purpose is to work with the file system. So file system provides you with basically whatever you want to do with file system, file system provides you with this functionality. You can open, read, write, close files, read, write without opening them, create, delete, read the contents of the directory, create new directory, etc. Basically, the functionality is only limited to what the file system is capable of and your imagination. So that's the important part. Node.js provides you with 3 types of file system API. The first one is synchronous. So if you use the synchronous API, you'll block your execution and the vault will wait until your file is being read or written to. Then you have 2 ways to use the asynchronous API, and this won't block your execution anymore since it's asynchronous. The callback style and the promises style. So the promises style should be a choice. You would like to avoid callbacks as much as possible to avoid this callback hell problem, and a lot of nested code is generated from callbacks, and just the promises is much more explicit way to use the file system API. And yeah, as you know, the Node.js is for a long time here already, and the JavaScript has faced many changes from 2008, as far as I remember. And there wasn't promises when Node.js was created, but they have created the promises, the way to work with the asynchronous code. And that's why there are so much, there are 2 different asynchronous APIs. So callback one is the outdated one, which always was there. And the promises API, which is kind of new, which was created with the promises creation. And one important thing I have noticed from my experience, like if you have some problem with file system and you open GitHub issues, most probably the issues are related to the callback API. So that's the API which causes you the most pain. The synchronous API and the promises API are stable, no issues with them, but you can face some problems when using it in a callback form. So I insist for you to use promises API, since it's a modern way of using this file system module. And yeah, that's pretty much it about file system. And now we can have a look at the Express library. And yeah, you might be wondering why I'm calling this a library and not a framework. And yeah, actually the framework is something which provides you with some restrictions. It can be your folder structure, the way your code structured, for maybe you can only write code in modules, or any other way of restriction is provided only by the framework. Express do not restrict you in anything. You can write code whatever way you like. So that's why it's library. And comparing to the frameworks, it's very lightweight, I would say. And Node.js just provides you, Node.js just provides you with some abstractions, and it using the HTTP module underneath. And those abstractions help you to get rid of the boilerplate code or anything you don't want to do manually, like the routing, for example. The Express provides you with a very convenient way of routing. So when in HTTP module, you need to parse the URL manually, Express does it for you. We will take a further look in the end, but do you guys worked with Express already, or or it's something new for you?
Yes,
Oh,
I
yes.
guess a little bit.
Nice, nice. So you're familiar with it, and it would
Yep.
be easier to explain. Nice. So that's the example of the Hello World application written in Express. You just need to import the Express, create an Express instance by calling the Express function, and then you can specify your root handler. This one is listening to the root of your application and just returns OK. And in order for this scene to start, to not break, we need to listen to specific port. But it's kind of the same as when you use HTTP module. So ExpressU provides you with very convenient way of routing your application. So routing is the mechanism by which your code got linked to the request your web server is receiving. So you can process the request which comes to the specific path. So that's kind of how the endpoint looks in Express, the root handler, so-called. So the app is the instance of the Express, method is the HTTP method. Yeah, so basically whenever you receive the request, it has HTTP method specified. Then you have the path as the first argument of the root handler. It's the kind of, in this example, it's just a slash, since we want to execute this code when we hit the root of the application. But it could be different. And we have the handler, which is the function, which is the code, the logic, which should be executed when we hit the specific endpoint. So that's kind of the example of how routing in Express would look like in the application. So you have 3 root handlers. All of them are listening to the all of them are triggered on different HTTP request methods. So the first one, we can handle the post request on the path /user. So we need to specify our web server /user, and you would hit this request. Then we have put user endpoint. So basically the same, but the method is different. And the important part here, the interesting part, as you can see here, we have :id, and it basically the dynamic value which comes from the URL. So you can imagine it like you type user / user ID, and like, for instance, if we have integer IDs, then it would be user /1, and 1 would become an ID in our code. So we can grab this parameter from inside the request object, and it is already parsed for you. So it very comfortable to use. You just access the params.id, and you would receive the value which you specified in this URL. And you can have more than one of those parameters there, but you should have different names specified for that one. So for example, ID, / email, and etc. And you can have them in your request object. And the same for the delete, which is listening to the same path, but the difference is this code would be triggered only when we send the delete HTTP request. So that's it about the middleware, but actually the killing feature of the Express is the middleware. And basically everything in Express is middleware. Even endpoints, even your root handlers are middleware as well. But what is the middleware? So the middleware is the part of code which is invoked on any request. It doesn't matter which path you're hitting or which HTTP method it is. Middleware would be called anyway, before any request. And important part here, in order for the middleware to be triggered before the request, it should be declared before the request. Since order matters in the express, and the middlewares would be executed in the order you declare them. So the first declared middleware would be executed first. If you have the root handler before any middleware, then this root handler would be executed before every middleware, and your middleware won't even be involved. So you can use the middleware to do some actions which are required to do for any request, like authorization, course, etc. Basically, any functionality which should be executed before any request should be done here in the middleware. And Express provides you with the huge, basically by using middleware, you can make your application very good. Like it's very easy to use, it's very suitable to use, and you would love to use middlewares. But yeah, Express is not everything in middlewares. You would just have 3 or 4 of them just to handle some basic stuff. And of course, your main business logic would be executed in your controller and then in the service. And yeah, that's kind of the way of how middleware would be executed. The first middleware is the first because it was declared first. The same for second and for third. And then we have optional root handler. And as I said, the middlewares are triggered whenever you receive any request in your application. So you might not have the root, you might not even have the root handler for this, for the pass the request is hitting, but the middleware would still be executed because the root handler is optional in the end of the day. So that's how the middleware looks like. So you just declare them by using use method, and you receive pretty much similar payload as in your endpoint: request object, response object, and the new object is next object. What is next? Next is a function which you would need to call in the end of your middleware, because this function invokes the next middleware in your middleware chain. If you type return instead of next, then your application would just stall because Express do not treat your returns as anything. The main object to finish the request is the response in the end of the day. And if you do not send anything in the response, then of course your application will install and the client would be hanging waiting for your answer. And as you can see, there are many libraries which can be used in the middleware, in the Express middleware, and there is a huge variety of those libraries, like body parser in this example, but the passport as well can be used as the Express middleware. The passport is the library which is used to handle the authentication in your application and with SSO or anything else. So in this example, we are just creating the middleware, which is using body parser.json. And this function is actually ready to use middleware, which was written for you by a very kind open source developer, like all JavaScript is. Okay, and we have the special type of middleware. It's the error handling middleware, and it's special because instead of receiving all the normal things, we're receiving an error as the first argument. And only at the end, we have request, response, and next. So what is this middleware even doing, you might be wondering? Yeah, this middleware catches every error which was being thrown before this middleware. So as you know, order is important in the express. And for the error handling middleware, it's not an exception. So in order for your error handling middleware to actually do error handling, you need to specify this middleware as the last one, because potentially you can have an error from any middleware, from any request handle, from any endpoint, and in order to react on this error, you need to specify this middleware last. And in case you have specified for some reason this middleware before, for example, your middleware, which is actually throwing an error, this error would, you kind of would receive the whole stack trace, and your node process might crash, and all the nice things which unhandled errors causing will cause. So yeah. Maybe you have any questions, because right now we're going to do some live coding with the Express. And before that, you can ask me something.
So this is a good approach and practice to use this error at the end of the mid-layer chain. Yeah.
Ideally, you would like to have this error handling middleware in your application, and I actually don't see the reason why you shouldn't, because why it's very cheap way to handle errors. Why not use it? And many frameworks provide you with such a functionality to kind of catch all of the unhandled errors. For example, if you have some insight on Nest.js, there are interceptors which are also capable of this functionality. And Nest.js is using the Express underneath, so you can expect to have this error handling middleware as the interceptor. So yeah, let's create something using Express. So here I have some sample project. For the setup for this project is pretty easy. I just have one script declared and Express installed.
Sorry.
Yeah.
I'm sorry. Can you please zoom a little bit?
Oh, sure,
Your
sure.
code editor. Good.
Is it good now?
Yes, perfect.
Okay. So here I have on line 13, I have installed types for Node as dev dependency to have the namespaces and the types available, even though I'm using the JavaScript, and the Express library, of course. And the Express is included in nodes, in types node, kinda. So in order to, let's create just a simple hello world endpoint. Light mode, yeah, sure. Let's do not the light mode. Let's do. Is it better? Can you see it? Do you like it? Blue filter, no blue light. No.
I
party
remember
light.
this meme when it likes light mode that works bugs. It's a meme.
Yeah, sure. Hopefully this application is so simple that there won't be any bugs, but Mexico mod, yeah, true. So in order to create the hello world application, we need to import the Express. Yeah, just Express, and creating the instance of this Express is just calling the Express function. Boom, pretty simple. Then we need to specify the port, which ideally should be stored inside of your .env file, but for the purpose of the demonstration, I'm specifying it explicitly in my only file I have. Then let's actually listen to the endpoint. Let's create the hello endpoint. Here we need to create request response, and now we can work with it. So we won't do anything special. We will just send hello. Hello, and that's it. And for for this thing to start up, we need to listen to port. App listen port. Look, no magic numbers, guys. It was already defined in variable, so no magic numbers. It's good. You should follow this approach. And to run the application, we basically you can do it. You can type this command in the console, but in order to make things nicer, I've created a script, and you can actually run any script from your package.json by saying npm run and the script name, and okay, it is started. So now if I go to the local host 1000 hello, I would receive hello. Nice, as we expected. Sorry for the line team in the browser. Hope your eyes are safe, guys. Yeah, now let's create the middleware. And intentionally forget to specify the without calling the next function, so you can have an understanding of what would happen if you do not call the next function here, and we will just log the request details to the console log, and details would be like HTTP method, which is request method, right? And the URL. It would be endpoint. And we can grab this from the request as well. And method, it would be right. And we need to restart the application. And now we can call the same endpoint. And we, okay, it's still method, but I need the URL, of course. Let's restart it once again and reload. And as you can see, we're waiting, we are hanging here because we haven't called the next function, and we would be hanging till it's timeout in the browser. So in order to fix this, we need explicitly call next function in order for our endpoint to be reached. And now we should receive hello. Yeah. We have the endpoint logged in the terminal, and we can actually, as I said, we can enter any endpoint, for example, this non-existing endpoint, and our middleware would be triggered because it do not require it doesn't require it for root handler to be defined for our middleware to start working. So that's the important part, and your middleware would be called on any request you receive. So now let's take a look at the error handling middleware. So let's create an endpoint which would throw an error, and it would be called throw error. Then specify a request, response, and we actually do not need them, and we just throw an error here because you shouldn't access this endpoint, and the error would be cryptic error, which we do not know about and how to fix this. And in order for this error to be handled, we are specifying error handling middleware. So error, request, response, and next. Yeah, so now let's just, our error handling would be pretty simple. We would just console log error message. Oh, yeah, and send 200. No, send error was caught. Error was caught. So here we go. Maybe any questions so far? I've seen something in the chat, but sorry guys. I will answer the chat questions after this demo. So now let's call throw error endpoint, and let's see how our error handling middleware would work. Throw error, is it right? Yes. So we see that the error was caught, and actually our application didn't break, it still operates. And we see the message in the console, which is the error message, and everything's good. But let's see what would happen if we specify the error handling middleware before the endpoint, which throws an error. And kind of, as you can see, as you would see now, order is very important when you define express middleware and root handlers. And as you can see, we are having the whole error stack trace, and it wasn't caught, it wasn't handled because, and only because, our error handling middleware was not specified behind the endpoint. Okay. Now let's take a look how we can use streams and buffers in combination with the express. So here I have some image. I want to see the contents of this image, and in order for that, I'll create the endpoint which would return me this image in the browser. But it would be image endpoint, and we need the request, the response, and boom. Now we can do the logic. So in order to read from the file system, we need to import the file system module, of course. So it would be require file system. Okay, now we can use file system, but in order to have the image path, we need to create something to basically, there is a known problem with the file paths between different operating systems. So as you know, in Windows, it's the backslash. On Unix system, it's the forward slash. And you somehow need to be able to handle those differences because your application can break, and ideally you want to have your application operating system agnostic. So Node.js provides you with the functionality to solve this issue for you, and we can use the path utility from Node.js, which would use the path separator, and basically will generate the file path, which would work on any operating system you would run your code on. It's not some magic, it takes a look at which operating system you're using and uses the appropriate file paths. So the image path would be, let's create a variable for that, and we need to use path dot join. So we have folder assets. Okay. And the file name is image.png. And notice how I'm using this join method. So I do not need to provide the forward slash, which should be actually a backslash in Windows operating system. Path will will join those two strings for me with the separator which is used in this operating system. So in order to get the image from the file system to the browser, I do not want to read the whole image to load it in the memory, but rather than I want to send it by parts. In order to achieve this, I would like to use streams. And it would be image stream. And this, we just need to create read stream from the image path. And we do not need to provide any encoding, so anything the browser can resolve for us. Browser is capable of sniffing the file we are sending to them. And actually, in order to to send it, we just need to image stream. We wanna to give every output to the next stream input, so we would use pipe for that. And we just need to pipe the response, and that's it. We can do some fancy stuff in order for our application not to break. We can create the error handling, do the error handling, which would and handle all the errors which we could potentially receive from this piping. So we need to listen to the error event. And in case we have any error, we'll just throw the 500 status code. And okay, it should be status equals. And send the string maintenance. Because of course our application is flawless and how maintenance. Yeah, thank you. Now let's run the application and let's take a look at the image. Okay, so that's beautiful cat saying. If you have any questions left, because it's the end of the lecture, hope you enjoyed it and hope it would help you in your further learning and yeah, anything else. So now I'll read the chat and answer.
May I ask a question, please?
Yeah, sure, please.
You did not use the async await in your endpoints, and is just for simplicity, or in real world applications we shouldn't use?
Yeah, actually, I do not have any asynchronous functions here, so I do not need to use async await. But for instance, you can use async await in order to do the piping, and for this matter, the pipe becomes pipeline, and you can wait for this pipeline, but since stream do not have the end, you might wait for a while, let's say. And in order not to stall the application by awaiting the stream, we just can do a simple pipe. But of course, if I had the database connection, I would write something to, or read from the database, it would be the asynchronous function, because I don't want to block the execution of the application. But it just, there is nowhere I can use async or wait here. All those operations are synchronous.
And another question, please. I saw very few tutorials about web workers in Node.js, and how it is in real world applications. Do you use web workers?
So yeah, web workers are in the browser environment. In JavaScript, we have child processes and worker threads. So Well, the JavaScript is able to handle everything in this single thread with the help of event loop. But in some situations, you might want to have a different thread if you have some high computing, for instance. Instead of executing everything in the main event loop process, you can call you can create another process, which is a child process, and do everything here, or you can create the worker thread. And basically the differences between those two are the way how they communicate. For the worker thread, the communication with the main thread happens by using the inter process protocol, and for child process, it just shared buffer array. So JavaScript provides you, Node.js provides you with such a functionality, but yeah, it's not used very often, but for sure you should know about it.
Thanks.
Sorry, I have a question. A middleware that is last in the middleware order will always have error parameter?
No, it's the only error handling middleware. So because it's the different type of function, thanks to polymorphism, you can have the same, seemingly the same function, but the different set of arguments might make the function implementation different, since the implementation for different type of arguments is different. And the error handling middleware is such an example, because it's seemingly the same as this middleware, but it has an exclusive parameter here, and it comes first because it's required parameter. You can't have the error parameter as null or undefined. It should be always defined, and it should be always error. And basically this error kind of switches how this middleware is treated by the Express. So it becomes error handling middleware. And yeah, that makes the difference, the first parameter. But if you won't have this error here, this middleware would behave as a normal middleware, with the only difference that it won't be called, since we are having an error here, and from this endpoint we are sending the response, so the request process is finished. So the specific position do not depend whether it's error handling middleware or not. So this error parameter makes this middleware an error handling middleware. And moreover, if you would have this middleware declared first, it won't be triggered, because it is triggered only when the error is thrown. So yeah, basically this error makes a difference.
And in this case, if we have this error handling middleware on the first in the order, will it get any, like, if we have error somewhere in the code, it will get or not this error?
So yeah, as we all figured out, basically the middleware are being executed in the order they have been declared. And when you declare the error handling middleware as the first one, there is no such an endpoint or middleware that can throw an error. So this middleware is a piece of code that would never be triggered. So it should be defined. It is the reason why this middleware should be last, because it makes any of those middlewares and endpoints declared have the ability to throw an error, and they can be sure that middleware will catch this error and do the handling.
Okay, thank you.
Yeah, so if no more questions, I'll have a look at the chat. How can I read it? Anybody knows? I'm not sure I understand it. So should we always use event emitter to catch errors when we work with streams, pipes, etc., and use try catch for rest, or combine both? Because in this demo, it's event emitter used there, and I'm just interested which is better practice. Well, it depends actually. For me, I like to have my error handling very explicit, and it's can be the explicit wrapping it into the try catch can do this explicit, and but if you do not want to do this, you might want to use the error handling event listener from your emitter. But the difference is when you wrap the specific code snippet in its own try catch, you would know for sure which errors it is capable to throw. But when you follow the approach, when you have just the big try catch around your whole code base, you kind of have so much options about which error you are receiving. So much options make your error handling very poor, and you might not handle your errors in a good way. But still, it depends on the project you are working on. And maybe there is a situation where all your event listeners are only capable to throw only one type of error. In this case, why not use the common try catch for all of them? Like, I mean, the event listener which listens to every event. So basically, it depends. There is not correct answer.
I have a question.
Yeah, please.
Why do we have next in error handling middleware? Because there is no next middleware after that it's last.
In case you actually can create another middleware here, which won't be error handling middleware. And in order to this middleware to be triggered, you need to call the next from the event handling middleware.
But if it's last, we still need next, or we don't?
No, actually, you can skip it. You do not need this next. Because, you know, the last parameter is, it might be optional parameter. And if we take a look at this type definition, then okay, those types are too complex for me this time, sorry. But yeah, it's optional. You can skip it here.
Okay.
And yeah, no influence, basically. So guys, was it a lot of information for you, or was it comprehensible?
Actually, both.
Actually, both. Yeah.
Both parts were very, very exciting and very interesting. Like, personally, me, I understood very much topics and very much useful topics.
Yeah, actually, to be honest, this lecture, when I was in courses, this lecture, I was looking at it and I was wondering why would I even use this? What is he talking about? I didn't understand it, but actually those are the fundamentals, and you start to understand fundamentals when you work more and more with the language. So the fact that you know know the things at this early stage, it might be it is very beneficial, to be honest, because those are the main mechanisms Node.js, and as you know, the Node.js has event-based architecture, and actually we have covered the streams and event emitter, which are mainly, which is used in most of in a lot of classes in Node.js, in a lot of modules and other third-party libraries. So understanding of these concepts like the event emitter, stream, buffer would help you a lot, guys, in the further course and in your further career. Of course, if you wanna write the Node.js applications. So yeah. Whew. Yeah, after the lecture, I'll send you the Rigs.js documentation and about this memory leak situation in Node.js. And yeah, that's it. If I have forgotten about something, please ping me, remind me, I'll send it to you. And in case no more questions, then that's it for today. Enjoy your weekends, enjoy your Friday evening. See you, bye. Thank you.
Thank you so much.
Bye.
Thank you.
Bye.
Nice weekend.
Thank you
Goodbye.
so much.
Bye bye.